Hi, I am Chetan, and I'm going to present a paper called as Trust in Recommender System, a survey. So, what do you mean by trust? What is the recommendation system, and what is trust in it? So, uh, recommendation system is something that we've been seeing uh, growing rapidly, and it basically recommends items to you, and do we trust it? How do we trust it? What are the metrics? How do we increase the trust in that recommendation system is the survey that we'll be doing actually. So with increase in the popularity of AI, these services are going to increase and increase in days to come. We already see these recommendation system in Netflix recommendation movies, Amazon recommended products, Google recommended news, Facebook recommended system, friends, Instagram influencer, YouTube videos, and etc. It's pretty much everywhere. So how do we trust the recommendation that we'll be getting? Is a key idea of this paper. So, uh, uh, outlining the paper, we basically decide on three aspects of the trust. So that is, we want our recommendation system to make sure that it is socially aware, it is robust, and it basically has explainability attached to it. So, what do you mean by social aware? Is we need to make sure the recommendation system is leveraging the social behavior of a person and also his peers. So basically, if I like something, my friends like something, what are we together as a group? We want our recommendation system to be aware of that, and based on that recommend our products, basically recommend anything that the system is supposed to put in. Also about robust. So uh, it should not it should be strong, secure, robust. So basically, we should not be able to fool the recommendation system. So if you look at the current recommendation system available, if in Amazon, if people put in random information, like let's say they create fake reviews and everything, and based on that reviews, if Amazon start producing recommendations, then will be then eventually we'll lose the trust in the recommendations provided by Amazon. Also, explainability is something that a recommendation system should have. Basically, we want to understand how did the recommendation system reach to at any point that it has. So if a recommendation system is telling watch this movie, how did it actually understand that I might like it? If it is able to tell me, how did it actually reach that recommendation? Eventually the trust will increase. If I don't agree with that recommendation criteria that it had, I might as well not follow it. So basically, it tells us, should I trust the recommendation system or not? So socially aware recommendation systems at this point of time is we collaborative filtering. It's pretty much an elegant way of a recommendation right now. And how the recommendation system works is, we basically have a friend circle, and we'll have a metric which calculates if a person is liking that product or not. So like that, eventually, me, my friend, and his likings and my likings, all together we will be recommending uh, items. Also, autoencoder based method models, in which neural network model helps us find latent factors. So these are latent factors are something that are not directly visible to us. Neural networks will find it out on its own, and then it will recommend the systems on us, recommend models or items to us. Similarly, there are like RNN models, GNN models. These are all high level neural network model, which basically dwell in sequential and time series data from uh, uh, from various sources, put it in a pipeline, run run these models on its own, and then basically have recommendation running. And these are all highly uh, GPU intensive, resource intensive models. And we usually don't get the nuance of how did they reach that recommendation. But yeah, basically the input to these is all our social activities in various ways possible. uh, and GNN based models, it follows the same way, but there is something called as hybrid methods. So what we do in this hybrid methods is, in parallel, we run all the recommendation systems and separately, and we ensemble them and then give it out, give the recommendations out. So this basically in social aware recommendation systems, just to repeat, we want to make sure that recommendation system is socially aware of a person's usage, likings, disliking, etc. That we get it, the data can be leveraged from Google, Facebook, or any personal information that he is ready to give in. uh, Using that information, we just want to make sure that we recommend right products to him. So robustness of recommendation system is something that is very much important. So as I mentioned earlier, merchants may hire a group of spammers to insert their profiles and fake ratings into the system, which will affect the performance of the recommendation system and also the customers trust in the recommendation system. So this is a kind of a very big problem at this point of time in recommended systems. So shilling attacks is something that we want to look into. So shilling attacks are the attacks where these types of attacks in which false, fake informations will be coming into the system, and eventually recommender system will slowly diverge into the false recommendations, and that is what something that we don't want to do in shilling attack detection algorithms. These are normal basic algorithms uh, where we have a different metric, and if let's say 1,000 messages come in at a time, we will basically say that it's a fake recommendation or fake metric. uh, if there are out of nowhere 1,000, 2,000 new reviews are coming randomly generated, we want to catch those transactions, and basically say we need to remove those transactions from the recommendation systems data set, and based on that we'll improve the way recommender system is recommending the products. Also, going into the next level of these shilling attacks is deep learning based shilling attack algorithms, in which once again there is input and there is output. We'll just have an input in which we say, boss, this is data set that we have, and these were shilling attacks, and these were not shilling attacks. So eventually what we'll do, deep learning models will do, is they will learn on their own, and we don't know how the weights are calculated, uh, basically, and I mean how the weights will be distributed. But it's known that deep learning is a black box modeling, and we'll not know what actually is happening inside. But in reality, these neural network models will find out what are shilling attacks and what are not, and using that we can basically make sure that our system is robust, and we are not susceptible to any such kind of attacks. Going to the last topic of the trust that is being outlined in the paper is explainability. So when a recommendation system is recommending something, I want to know how did it recommend. For example, I was let's say I was recommended a movie called as The Bunk 3. How did it understand? So these kind of explainable images will help user to understand. So for example, my neighbors rating for this movie is 4. There are two people who like this same movie, there are three people who like that same movie. So yeah, maybe I might like it, is what is being uh, told to us. So using this information, yeah, I can trust this because in my area, in my social area, there are like 7 people who like this movie, and they have given a pretty much good rating, and therefore I like it. Is something that we want to explain the user of the system. And also, when it comes to explaining textual data, we want to make sure that we explain textual data. Right now Google provides uh, news recommendation systems to you, the way you deal with searches and everything. So what we want to do is we want to explain how did we reach that kind of recommendation based on text. So what are the keywords that I have previously searched, what are the things that I have read, and what are the items in those materials. We want to cross reference that, have our recommendations available to us, and also on the go we want to tell users what are those words, points, anything, basically our data set that led to this point of this type of recommendation. So for example, if somebody is showing me best hotels in Arizona, for example, and pretty damn cool and pretty best in Arizona. So our recommendation thinks that I'm interested in something of pretty damn and Arizona. So this is something that I like, and I want to see best things around Arizona is what we think, and therefore we are showing other best things available in Arizona. That's some kind that's a, a dumb way to put it. Uh, Basically, what we want to do is we want to tell users how did we reach this specific recommendation based on the keywords that we have selected on the textual data. And last is the visual data that we want to tell. So for example, if somebody is searching something in Amazon and I select, I basically get these types of recommendations. So let's say I'm given these kinds of t-shirts. Why is a question that I will have. Why am I getting this kind of recommendation? If I basically click on that and if I see why was that recommended, if these kinds of information is showed to me, then yeah, I might trust the recommendations. So basically, see, uh, this kind of uh, recommendation is based on my previous searches and my buying uh, history, uh, my order history. I usually like short t-shirts and short sleeves, basically, and therefore I might like short sleeve t-shirt. Is what my recommendation system is thinking. If I've been wearing usually buying a trouser length of full and a kind of tight pants maybe, and this is basically the way we thought a recommendation system is calculating, and this is how the recommendation system is throwing me the recommendations. For example, here I this lady loves a short dresses, or basically dresses, and therefore the dresses are being shown here. Jackets, usually a body length of a micro size, and a, a t jackets is what recommendation system thinks is important for that user, and these are the recommendations that are thrown at. So yeah, these kinds of explainability will help. So there is some kind of special recommendation that will also come in handy, is visual data plus NLP. So if a user has somewhere to put a statement on a tweet or something which says I love the pink, we basically, our recommendation system will understand, yeah, this user loves pink, and eventually that information is captured, and also my browsing history, also my buying history, all of those things cultivated in one model will be getting something of this sort. So these are the images, these are the recommendations that were produced based on these types of searches. So I love the pink, and therefore the pink dresses, pink jackets. It's a beautiful and nice style here. Like I like it. So somebody, so this is a socially aware example in which my recommendation system is understanding that I like something of this sort based on my social behavior and is recommending me the system. So this is how we basically tell it. Uh, we need to have a socially aware, explainable and robust recommendation systems, and the metric that will be attached to it is going to tell the way these are going to improve the trust in that recommendation system. So the conclusion is we have discussed various techniques in which we can establish trust in the recommendation system. With days to come and the advancement of artificial intelligence and machine learning, the trustability of these systems is going to be the key factor, and this was a paper as a step towards that future. Thank you.